Hey guys, welcome back to another video. Today we're doing Leetcode 3249, count the number of good nodes. So in this problem, we're given an undirected tree. It comes in an adjacency list, so we're getting a list of edges here. And we want to find out how many good nodes there are in a tree. And they tell us that good nodes are nodes where, if I can move this, where all the subtrees rooted at its children have the same size. So basically, all that means is if you have a node, say this is a good example here. I mean, all these nodes in this example are good nodes. You see that to 0, the left has 3 nodes here, and the right has 3 nodes here. And then, with 1, its left has 1 node and its right has 1 node. And then even this one right here and this one right here, left and right both have 0 nodes. Those still count as good nodes. And then, same thing for all these other nodes as well, obviously. Let's go down here. I have another example. So in this problem, this one, only these leaves here and this node right here are good nodes. For example, this 2 isn't a good node because it has 3 to the left and 1 to the right. Obviously, all these all have 1 to the right and more to the left. So only, let's see, 1, 2, 3, 4, 5. So only these 6 are considered good nodes. So anytime we're working with something like a tree, we know we're either going to be doing DFS or BFS. Normally for trees like this, DFS is just easier. And that'll allow us to hit both left and right at the same time in an easier manner. And then all we're going to want to do is we want to count the number. Whoops. Let's use a smaller font here, but we're going to want to count the number of left and right nodes. And then just check if it's equal. That's pretty much the whole problem right there. So let's get into Leetcode and we can start coding it. All right, we're back here in Leetcode. So anytime we have a list of edges, we don't want to just put into data structure so it's easier to manage. So we can make a tree object here from a default dictionary. And this isn't undirected. Edges are undirected here, so we're going to have to put these both ways. So have to append them twice. Then let's create just something to hold our answer and return that. That's what we'll increment when we find a good node. And then what we do is called DFS on 0. They tell us that it's always rooted at 0, so we can just call DFS on 0. It's called DFS here. So we just said size equal to 0. We don't really need a base case here because we're only going to call DFS if we have a node, since we're going to be looping over the list we have. And so we'll never have a none or a null node, so we don't have to worry about it. Something like a null pointer. So see what I mean here. So this will, since we have a default dict, it'll just return 0, or an empty array. Sorry, if it doesn't exist. But something we're going to want to do is skip over if we get the parent, because it's an undirected tree. So every time we'll get the parent node that we already traversed. So let's just do that. We just call -1 here. We just continue. I will want to get the subtree size. Here, and something to note, it's not necessarily a binary tree. It can have, a tree can have as many children as, as possible. So we're going to want like a list We actually use a set, actually, in this problem to keep track of the sizes we found. And the idea here is if we have more than one item in the set, it's not a good node because that means the children had a different amount of nodes beneath them. So use a set as a little trick here. And then we can add subtree size. And we should actually set size equal to 1. And then we're going to want to also add subtree size to the node. Oops. Okay. And then all we're going to want to do now is check child sizes less than or equal to 1. And it's equal to 1. Oops. It's actually, we can't directly in Python call it ands like that, so let's make it an instance of the solution class. And then just return size for the upstream calls to hit and get that size. But that's pretty much it for the problem, so let's run it now, make sure it passes. Yep, there we go, all cases pass, we can submit that. And there we go. So if anyone has any questions about this problem, feel free to comment below. If you have a specific problem you would like me to try, be happy to do that as well. But thank you for watching. I hope this helped.